on C++. We'll be talking today about strings. There are types of strings, but in particular we'll be talking about C strings, which you may find in a lot of legacy code. In fact, a C string is considered to be an array of characters. To define a string, we need to specify that it is going to contain characters, and we can give the name to our string, and then we can use our square brackets to denote that it's a one-dimensional array, and then we can initialize the string. It's interesting to take a look at this string in memory. So what I'll do, I'll put a breakpoint in here, and I've got some windows open, a memory window and a local window, which I got from here. If you go to debug windows, you see you've got your local window and then your memory window there as well. So I'll run the program to there, down to the breakpoint, and the windows will then appear when the program is running. And I'll take a look at the memory location of the string. So if I hold my mouse on there, you may just be able to see the address there, 003 CFAFC, which I can see that in the locals window down here as well. The address of the string is that. But let me just single step and take a look in memory. So 003C F300, if I put that address in here, 003C FA5C, the hexadecimal address, of course. So if I press enter, you'll there see the string. You see, there it is there. It's ASCII characters at the moment, single byte ASCII characters. For example, 61 is hexadecimal, for 616 is 96, plus 1 makes 97, which will represent the small letter A over here. But notice something interesting for our string. It's got this 00 at the end, and they're quite famous for having that byte terminate a 0 terminating byte. These are particular to C strings. It tells them where the string ends. It's a good idea to focus on this address here, 00 hexadecimal address, which is the address showing here as the address of the first character of the string, which is the F. Now this is very important. It's the address of the string, the address of the first element. Now str is a variable which holds that address. You could say it's a pointer to that particular address. So it's a variable which holds the address. It doesn't actually hold anything else, not the strings or the string itself. It holds an address to the string. It's very important to understand that. Okay, so I'll stop the program, and how will I print out the string? And you might say, well, maybe I'll use square brackets like this to print out the string. Well, no. And the reason is that this cout is expecting an address. It'll know it wants to start at this address, so I don't need the square brackets. This is a variable which holds the address. Now cout will say, oh, okay, you're giving me the address of the string, thank you very much. I will start printing out all the characters. How will I know when to stop? When it reaches the 00 byte. So this is the address of the string. And indeed, if I take the breakpoint off and run the program, you should find that the address is, the string itself is printed out. So let's say I wanted to print out the second element in the string, say this element here. I want to print out the A, for example. How would I do that? Well, it's an array of characters, so I'll treat it like an array, and I'm going to talk about the second character in the string. So what will the second character be? Don't forget, it starts at 0, so the second character is going to be element 1. And so when I run that, you'll see that the second character is indeed printed out, being the A, but denoted by the 1, because the first character is str0, would give you the F. Let's say we, for an exercise, we wanted to put two strings equal to each other, but we wanted to do them character by character. There are functions which will allow us to do this more simply, but for the exercise we're going to so I'll make the second string big enough to hold the first string, or even a bit larger, and I'll create a loop to the length of the string, which is 9. Now it's got 9 characters. We're not going to be copying the well, we are going to be copying the last element, which is the 8th. So we have 0 to 8, which is 9 characters altogether. So that will include the last 0, 0 will need to be copied across as well. So we can place character by character, one given to the other. Well, I should have distinguished the strings in the first place. That wouldn't have been very useful. So now they'll be transferred character by character, meaning that the elements of ST1 will be placed into ST2. So in other words, from here to here. So farewell ought to be transferred to there. So if I wanted, therefore I want to print out my second string, which I should be able to do like that. Well, I can see a slight error. I think I've got too many characters in my string, or I could have altered this, but I'll just make the string a bit smaller. That means it's got 8 characters, which means we want the 0 to 8, which means 9 characters altogether, and that will include the 0 terminating byte. So if I just run this, I indeed get the C2 string being the same as ST2 is the same as ST1. We could use the str, the string length function, to generalize this. So we could try, instead of 9, we could put that, but the length, that will be the length giving 8. So we could put an equal in here, might be the easier way to do it, or we could just add one on to that. I guess I should make sure that that is an integer value, and then if I run that, I'll get the same. I'll get farewell printed out, which is ST2. Well, to copy a string, it'd be easier if we use the string copy function. I'll just comment that code out and replace that by the string copy, which will copy ST1 into ST2. Incidentally, that function is just expecting the addresses of each of these strings, and that's enough to copy from one to the other. We used to use the str copy, but that's now being deprecated, being a little bit dangerous on memory, so we now use the _s. But these are quite old-fashioned, if you like, functions, but they still abound, so we need to be able to deal with them. So if I were to just run that program, then we should get the second string printed out, ST2, which is indeed the same as the first. We could concatenate two strings by using the string cat function. And I'll use these two strings to concatenate one to the other. And that's the deprecated function, so I'd better use the non-deprecated version. And that means that ST2 will be added on to ST1, so house will have boat tacked onto the end of it. So that's the one that I want to print out, is ST1. So using the concatenation function, when I run that, I should find that the two strings are joined together to produce houseboat as required. We'll talk about the string compare function. When I want to compare two strings, well, just for the moment, I'll make them both the same. We don't need to say how many elements there are if we're initializing to this fixed length string. So I'll need to print out the result of that. Now if I run that, I get the value of 0, indicating that the two strings are identical. But if the string's not the same, we can test if they're lexicographically bigger or smaller. In simple terms, that means if it comes before it in the alphabet. And if we were to run that, because it does come before it in the alphabet, we'll find we'll get a -1. But if we try it the other way around, where this one is after it in the alphabet, and then we run this, we should get the answer of +1. A very important function is one that finds whether one string is contained inside the other. For example, SE, you can see, is definitely contained within house. So the function that we use is the str function, which indeed will find if st2 is inside st1. So we just want a yes no at the moment, so we're just going to say if it's, now we need to be careful it doesn't cause an error here. We say if it's not equal to null, then we need to do something like print out that we've actually found something. We found one inside the other. So if we were to run that, you should find that that was successful. In other words, this string was found inside this string. So you can imagine how useful that is when you're handling lots of data. You want to know if something is inside something else. A bit of data is inside another, might be a CSV file, for example, that's been output. So how do we actually find the position of the S inside there, which is that position there, which is 0, 1, 2, 3, counting the first position as 0? Well, it's not as easy as it looks, actually. So what we need to do is to set a variable equal to this, because what this thing here is a pointer. Now it's a pointer to the position in memory. Now we haven't really dealt with pointers much, well, at all. So just bear with me and I'll just try and explain. So I need to actually define a pointer. P1, and then put P1 equal to the result of that. Now I showed you previously the memory locations. Well, P1 will actually hold one of those memory locations. Remember the hexadecimal numbers 0x such and such, quite a long address in hexadecimal bytes. So this will return the position of this S, which is, sorry, so that's 0, 1, 2, 3, yeah, 3, position 3. It will hold the position of that S actually in that physical memory that I showed you before. So it becomes a little bit complicated, but what I really need to do is to find the address where the string starts, which is not a big deal, and then subtract those two memory locations. Well, how do I do that? I need to just print out the difference. So this is the address of where the S was found in memory, the memory location. But remember, st1 holds the address of the start of the string. So it shows you where this H is in memory. So if we subtract those two hexadecimal memory addresses, there should be a difference of 3 between them. so that if I output that, it indeed should give me 3 as being the position of the S in here, starting at location 0. Of course, 0, 1, 2, 3 is where the S is. Now, if that's a little bit complicated, not to worry, just use it. Just remember to use that formula, if you like, where that is the address of where it's found, and this is the address of the location of the start of the string, and you subtract them, and there's a difference of 3 between them. Another function you may see sometime is this string set. All that does is takes the string, which is house here in this case, and replaces it, every string, with this character here, which happens to be an asterisk, so that if we were to run that, indeed it's been replaced by 4 asterisks. We've been dealing with a single string. Let's talk about an array of strings. So instead of having one single string, now look at the notation here. We've got the square brackets, just like we used for 2-dimensional arrays, where you've got square bracket, and this is the number of elements, the maximum number of elements in the string. We could put here, optionally, we could put 3 here to the number of strings, but in this case it will be 3, so we could or could not have that 3. But I think it might be useful to take a look at this array of strings being a 2-dimensional array. I think it'd be very useful to look at it in memory. So I'm going to run the program down to here and take a look at the memory windows. And find the address of the string first of all. See, if I run the program down to the breakpoint, I take a look at this st1. Well, I'll just advance it 1 by F11 and just take a look at the address here of st1, which I've got in my locals window down here. So I'll type that into my memory window, which is 003. You can just see that down there. 003 F7 0031 F7 AC, and if I press enter on there, you can see the strings. Now you'll notice they're all 5 bytes long, and even ed takes up 5 bytes with some 0 padding at the end. You can see it's very wasteful of memory. There's a way of dealing with that waste of memory, and that's by using pointers, which we'll come to later. But for the moment, they're all fixed length, and they've all got 5 bytes because John takes up 5 bytes. Don't forget, including his 0 terminating byte as well. So you can see here as well the addresses of the individual strings. Here, there are 3 of them there. But you could, it's a little bit confusing this, that st1 could be considered to be an array of those pointers. Well, why do I mention this? Because if we want to print out each string, then we would use this. Then to print out the first one, you can think of them an array of strings, an array of addresses, I should say, of strings. A little bit confusing. But if you want to print out the first string, you print out the string whose first character is given by that address. Now remember that cout is expecting an address of the first element of the string, which is what that is. So confusing, yes, but that's the way that you print out the string. Let's see if that indeed will give us the first string. And if we were to print out the second one, this would be 1 would print out Joe, and then 2 would print out John. Takes a bit of getting used to. There's quite a lot involved here. that this is really considered to be an array of pointers. An array of pointers to strings. The pointers actually point to the strings. They're the addresses of the strings. So cout is expecting an address of the start of the string, and these are 3 successive addresses to starts of strings. But just to get used to the notation, if you're printing it out, just use a single index. As an exercise, we could have this print function to which we wish to pass our array of strings, and inside that function we want to print out the strings. So I could leave you to do that for an exercise. A little bit tricky, how you're actually going to pass the strings to this function. The function is not going to return anything, so we could qualify that with the void, but it is going to accept the string, an array of strings. Now that's the tricky bit as to what it accepts, but we're going to call our print function somehow or other to print out the strings. Don't forget that you should have your prototype, that's not complete at the moment, but you need a prototype, and therefore you need to know what needs to go in here as well. I'll leave you to do that, and just pause the video, and I will then proceed to show you how it's done. Well, our print function is only going to need the address of the first element, the first array of elements, the array of strings. So you just need to pass that address, which is quite efficient, of course, because that means you don't have to pass all the strings. You just have to pass the address of the start. That really is the key to passing an array to a function. But the tricky bit is when we're passing to a variable, we're passing st1 to this variable. Well, that's not much use. We need to qualify it with something and say what type of variable it is. I mean, what is it? Is it a character? No, it's not. Remember, this st1 is actually a pointer. It's a pointer to the start of the array. So what we have to do is to say that this s is the same as this, so to speak. In other words, it's an address of the start of the array. So that you'll be passing an address to an address. So how will we indicate that s is this address of the start of the array? Well, we need to say that it is a pointer to an address, so we need to use the same notation. So now that's saying that s is a pointer to the start of an array. Now that may be a little confusing, especially when I don't put the s in the right place, but what's basically happened is that you're passing the address of the start of the array to s, which is also a variable of that same type. In other words, the address of the start of an array, which ultimately holds characters. So this address is passed to this address. Then once you've got the array, the address of the array, that's all you need to go printing out characters or strings. We might just try to print out one of those strings. Remember, it's just a single index because this is considered an array of pointers to strings. So this is the first element, so it's the first address. So there's one thing we've forgotten, and that is to fix up the prototype. And so we could do it thus, and remember, you don't really need to include the variable in the prototype, but you must remember to put a semicolon there, so that if we build that and run it, we should print out the first element in the array, the first string, which indeed is ed. I do realize that's a bit tricky, but I must say I found it tricky myself when I came across it. But the key really is to understanding what this thing is here. ST1 is this address here. It's an address. It's an address to the array of strings. So you've got 3 of these ST1s, so to speak. There are 3 pointers, and they're each pointing to the individual strings ultimately. And this is why you see, for example, S0 will represent the first string to be printed out.